Welcome to Fisher Webinars. The following is a recording of Water Everywhere, or is it? Originally recorded on Tuesday, December 11, 2018.
The topic for today's Fisher webinar is water. Is it everywhere or it is not? And we'll find out more about it as it pertains to the paper industry. This is a webinar provided by Fisher International, which provides the business intelligence services to paper industry worldwide. The service is available through the FisherSolve software platform and the new web-based platform called FisherSolve Next has made the use a lot easier. And whatever I'm going to present in this webinar with respect to water is available only in this FisherSolve Next platform. As with any other application within this, you can use it to visualize the data, visualize information, do the analysis, gain insights in the business, make decisions, whatever required to succeed in paper industry. So given that, let's get down to the business at hand, which is the water as it relates to pulp and paper mills. As we all know, water is the essential ingredient in pulping and paper making process. It is something that we gotta have. Paper mills use various raw materials and fuels, but most raw materials, they are consumed or converted in something else. Wood chips are converted into paper, fuels, whether fossil or biomass, converted or oxidized into carbon dioxide and other gases. But water, even though it's essential, it's not really consumed or converted into anything else. All the water that comes in is discharged as effluent. Effluent may contain some suspended solids, these are organics, coloring materials, things like that. They had to be removed. But still, the water as it leaves is still the water, same as what comes in. And some water is evaporated. And whatever is true for paper industry is true for all other industries and even for human consumption. We take in water and we discharge water. What that means is the worldwide availability of water really does not change. So if that is the case, then what is really the concern? And the problem is the local availability of fresh water. Obviously, wherever you are, you had to have fresh water available. And that availability may change over time. And that may happen for various reasons. So if we can identify what the risk is of freshwater availability at a given site, then that makes it easy to know what lies currently or in the future as far as water and take appropriate decisions. So the first thing we need to know is what exactly is the water risk at a mill site location. And for that, we turn to World Resources Institute, or WRI, and they had done a fantastic job mapping almost the entire world in terms of the water risks. So they called it the AQUEDUCT Water Risk Atlas. This is from the website, and color coding is light yellows are the low water risk, the red, as it gets darker, is a high water risk. And if you go to their website, the map is interactive. You can click at any location and you can find out what the risk is at that location. Or it can enter an address, or you can enter a latitude, longitude for that particular location, and you can get information as well. So that's made it easier to know what the water risks are and to use it. And that's what we have done in FisherSolve Next. So this gives you a website address if you want to go there and directly look at their map. Obviously, the water risks are quantified and expressed on a scale of 0 to 5, where 0 is very low and 5 is very high risk. And the risks are in 3 different categories. There is a quantity or the water availability risk, the quality, and a regulatory risk. And we'll talk a little more about it soon. So what we've done is we've taken all these numbers for latitude and longitude of the pulp and paper mill sites, which are part of the Fisher Soil database, and then collected information for the water risk and made it part of our group of data in Fisher Soil Next. Why is it important for the pulp and paper mills to look at a water risk? If you say water availability or the quantity, if the water is not available in sufficient quantity, then obviously the, the mill has to look at reducing the usage of water, and that can be done in a number of ways. Have more efficient showers or vacuum pumps. Those are probably the two biggest applications of fresh water in almost all paper mills. Simultaneously, the mill can look at increasing recycle or reuse of water. And in order to do that, quite often you have to clarify the water to make it suitable to replace the fresh water. And then you need more cleaning and screening equipment. If the water quality is at risk, then the mill will have to look at treating the incoming water if that's not suitable for direct use. And also, there may be some additional limitations on effluent discharge to make sure that the quality of that source of water is not degraded if that's what you're discharging. And a regulatory risk is obviously site-specific in terms of what the effluent discharge requirements are in terms of the quantity and in terms of what's in it, such as the suspended solids, dissolved organics, or color or pH or whatever else may be depending upon the local conditions. So this is what makes it water and the water risk numbers important and relevant in terms of why we want to look at them. Okay, so now that we have the water risk factors or numbers in the Fisher Soil database, in addition to all of the data at site level that we have, what can we do with it? We can do a lot of things, or anyone that's using the software can do. First of all, I can visualize the information. You can analyze it by itself or in combination with any other data, and then gain insights and generate reports as it pertains to whatever task is at hand. Okay, so the first step is can visualize the data. So this is the map from Fisher Soil Next, so North America, and the markers are the pulp or paper mill sites in Canada, US, and Mexico. The color coding, the green is a very low risk from 0 to 1, and the red is a very high risk, 4 to 5. Obviously, the risk is on a scale of 0 to 5, 5 being highest risk, 0 being lowest. So what we see on the map is certainly there are a lot of green markers. So a lot of sites are very, very low risk. So they have plenty of water available, plenty of yellows and oranges. So their risk is low or medium, but still have a good number of red markers. So that means those are the sites, some in Midwest, some in Southwest US, plenty in Mexico, that at that specific site location, the risk for the water is a little high. Can zoom into the map. This is the Midwest part of US and Canada. The white areas are the Great Lakes. There are 5 Great Lakes, probably the largest source of fresh water in the world. Does that mean that there's plenty of fresh water available all over the region? Well, if you look at the water risk factors, then the answer is decidedly no. In some cases it is, but it's not always. We see greens where it's a very low risk, a lot of yellow and oranges, but we see a number of red sites. So what that means is the water risk is very local, very specific to a site that you are at. It may be just a few miles or kilometers away from a larger source of fresh water, but still that site may not be able to get that water. So in that case, obviously, the risk can be high or very high. Uh, so, so the point is, the water risk is really dictated by a very local conditions, by very local conditions, and uh, it you cannot really say that there's an average for a state or a country or area for a water risk. It's a very local phenomenon. So one needs to look at whatever the conditions are at that local site, and that's why the numbers, site-specific numbers, become important. Okay, uh, can visualize other parts of the world. In this case, I'm looking at Asia Pacific. We got India, China, Japan, South Korea. China is the largest producer of paper right now. So if you look at China, you see plenty of yellow and oranges in the southern part of China, but there are large number of sites in the northern part of China. There are red and dark red. So obviously those sites really don't have, may not have plenty of water available, or they are at risk in terms of water being available all the time uh, in whatever quantity that they need. So this is obviously the first thing one can do is visualize the information. Now that we have numbers from 0 to 5, we can uh, look at the numbers in terms of where the paper is being made. So in this case, this is a bar graph where y-axis is the production, tons per year, and what the risk is, depending upon what the for the production. And the bars are for different regions. So if we look at, for example, Europe, it's the yellow bars, and there the risks are low or median. So most of the capacity is less than 3 in terms of the water availability risk. There's a small capacity in the fourth group of bars, 3 to 4 range. Same is true for North America, which are the red bars. But if you look at Asia Pacific, certainly there's a good percentage that is a risk lower than 3, but it's here substantial capacity at risk, high risk between 3 and 4, and certainly there is enough capacity at very high risk between 4 to 5 as the extreme right-hand group of bars. So this way, this is one way to visualize where the problems are in what parts of the world. Now, this particular graph is for the water availability, so it's just a quantity. Since we have risk factors available for in 3 different areas, we can look at the other areas as well. So the next one is the water quality. Same type of graph, production or capacity on the y-axis and the risk on the x-axis. And again, we see a little higher risk for the between 3 and 4 for Europe and North America, and Asia Pacific continues to have high risk and enough capacity in the high risk area between 3 and 4, and also between 4 and 5. Those are the blue bars. The third item in the water risk is regulatory. So in this case, it's kind of different. See the Europe and North America, which is yellow and red bars, the risk is very low. What that means is the regulations have been in place for a long time, and almost all production capacity or all mills are in compliance with those regulations. So there is no danger for additional risk related to regulations that one foresees in near future, and that's why that risk is low. But in Asia Pacific, we see a higher risk, probably because either all regulations may not be in place, or they may not be enforced as rigorously. Paper mills may not be in compliance with the regulations. There may be need for comparable regulations or stricter regulations, and that's why the risk show is very high uh, in Asia Pacific in this area. So this is the information that we have available in Fisher Solnex in terms of the risk in three different categories for every uh, mill site that we have in the database. So with all that, one of the first thing we need to look at is, we know that water is essential in pulping and paper making process, but are the needs for water same for all mills? And the answer to that is, it's really no. It depends on the grade and the type of the mill. So first let's look at the grades. Here I have a bar graph for different major grades as per our classification. And the y-axis is the water usage, meter cube of water per ton of paper. And here we see that the market pulp has the highest need of the water usage, and all other grades are lower compared to the market pulp. So, and the pulp mills in general need more water as compared to the paper mill. We distinguish the two operations, and that's why the market pulp always in need of a higher amount of water. So let's look at the sites that are making market pulp. This is the graph where y-axis is again water usage, x-axis is the water availability risk. The bubbles represent a mill site, the size of the bubble proportional to the production, and the color coding is by the region. So you see the reds are North America, the yellows are Asia Pacific, and likewise the legend is at the bottom. Anyway, I put a marker here at 2.5 for the water risk, and we notice as majority of the sites are to the left of it. That means most of them are really not at very high risk. And that is obvious because anyone who establishes a market pulp mill, one of the first criteria is going to be that site has to have plenty of water available, simply because the operation needs a lot of water. So all these sites have been located where the water is available, but obviously one has to keep in mind that the mills operate for years, decades, sometimes 100 years, and the water availability may change over time. And that's why knowing what the current risk is and how it is likely to change in the future becomes important. But again, in general, the market pulp mills are at a lower water risk than what we may see for other type of mills. Okay, water usage also depends on the site type, and this is where I'm just separating between non-integrated, recycled, and integrated mills. The last group of bars are the integrated mills, virgin integrated mills, and they have the largest water usage. That's the y-axis. That's the site. Those are the sites that are a pulp mill and a paper mill, the same site. And recycle mills making the same grade of paper generally use half or less than half of water as compared to a virgin integrated mill making the same grade of paper. And so that makes it important in terms of the risk. Obviously, the water risk is more important for the integrated mills and less important for the recycle mills, simply because the usage is recycle mills don't have as high a water usage, and they have a greater potential for reducing their water usage. The third group of bars is the virgin and recycled mills. So obviously they're in between the recycled and integrated, and their actual water usage would depend upon the percentage of recycle that they have. The first group is the non-integrated. So these are the mills that buy market pulp, mostly dry lap pulp, and make paper out of it. From the standpoint of water usage, that is using dry pulp or market pulp as a starting point and using dry waste paper as a starting point, it is similar as far as the water usage is concerned. And that's why we see that the non-integrated mills and the recycled mills have similar water usage patterns. So they are always going to be in terms of the low water usage. So given that background, we can use combinations of these factors in order to look at the risk numbers. And I'm going to show you some combinations. Obviously, there are numerous possibilities depending upon what one's needs are and what the applications are. So as examples, the next graph, I'm looking at water usage versus water availability for the packaging, North America. Here you can see that the recycle mills, that are the blue bubbles, pretty low water usage, but they are in a high risk area as well. But obviously the risk is not a major factor for them since their usage is low. All integrated mills are in a low water risk region. Obviously by design, they've been cited there. Can look at tissue and towel grades. Here I'm looking at a combination of virgin integrated mills versus non-integrated mills, since there are a lot of tissue mills by market pulp use it. And this is for Asia Pacific, so you can do the analysis depending upon the region or depending upon whatever combination that one has a need for. Another way to use the information together is look at the viability. The Fisher-Sol has ranked all paper mills in terms of how viable they are. It's ranked, viability ranking is low to high, where high means mill is less viable or the survival risk is high or less likely to survive. So the ranking for the viability is high and the water risk is also high, then obviously the two combined make the milk more riskier. So in this case, the markers are at the midpoint for both viability and the water risk. The top right-hand quadrant in this case is where the viability ranking is high, so that risk is high. At the same time, the water risk is high too. So if you look at the mills there, then you have plenty of mills in the blue bubbles, which are in the Asia Pacific. This is a graph for Asia Pacific and North American mills. So there are plenty of mills that are determined to have a higher risk from the viability standpoint, which takes into account the cost and the size and the technical age and capital required and other factors. But at the same time, they're also high in terms of the water availability. So on the other hand, if you look at the bottom left quadrant, that's where the risks are low, both categories. So this is one way one can look at the information, visualize it, analyze it by combining different types of data. So this is, I mean, there are a number of other ways that can be done as well. But I thought this was the idea here is to present some of the easier ways to do the analysis, show the results, and that will hopefully lead to more intense analysis on the user's part. Some of the things that all the paper mill sites have to look at is how the freshwater or the local availability of freshwater is going to change over time. And the changes in demand, and there may be competing industries or population growth in that area that may put more demand on the freshwater. The climate change can change the pattern of freshwater being replenished or being available in that area. Seasonal changes in precipitation can happen where you may have paper mills run all through the year, but we have more water in one part of the year and a drought in the next 6 months, then obviously there are problems. And The last one is probably the most important, is the recharge of underground aquifers. This is a this is an invisible problem. We don't see it. Most people are not aware of it, but there are plenty of paper mill sites that rely on underground water or the groundwater for their supply. And if these aquifers are not recharged adequately at the same rate as the water withdrawal, then obviously there's going to be a problem, which can happen with very little notice. And then uh, there may not be options if you don't have another source for water. So with that in mind, there have been some items in the news recently that related to the water, and we can kind of look at those with respect to the water risk. One of the items was from a ChinaDaily.com, where the Chinese government has announced that all paper mills near Dongting Lake in Yunnan province are going to be closed in 2019. There are probably about a dozen paper mills in that area. And this particular lake is the second largest freshwater lake in China. So it's kind of ironic when you see that phrase. So when you say second largest freshwater lake, that means there's plenty of water available. So the availability is not at risk. But obviously, what they're looking at is, number one, is the second bullet item says it's the outdated paper making capacity. Maybe so it's just the viability of those mills that is at stake. The third item says they are causing pollution. So that means obviously there must be an importance for that fresh water to stay in good condition. So there may be more demands for that fresh water for some other applications, which may be more important than making paper. So regulatory risks are probably high here. It's not the water availability risk, but the quality of water may be a concern for the Chinese government in terms of the demand for that water for some other applications. So this is an example where the water is an important element, and it kind of shows up in terms of effect on the operations, or in this case, just the survival of these mills. A recent report released by U.S. government on climate change impacts in the U.S. has some interesting conclusions. The chapter 3 of this report is on climate change impacts on water resources, and I have extracted a few bullet points out of that chapter. The first one is we've seen a lot of high precipitation events like big hurricanes that dump lots of water in a very short time period. And what the prediction is, those types of events may increase, but at the same time, the dry spells can increase too. What that means, you got a seasonal variation of water supply. You may have flooding during certain times of the year and may have no or less water in other times. Also predict there may be longer term droughts. They may intensify in areas of Southwest, Southern Great Plains, or Southeast. The third is probably the most important, is the effect on the groundwater, aquifer recharge, reducing the groundwater availability in certain areas. And I'll show in the next slide what the groundwater usage is. And the fourth bullet point is all these climate change effects may affect the quality of the water, and that may put some restrictions on either the usage of water or what you can discharge into it. This is a map from the same chapter. It's a groundwater withdrawal by county. So in US, so each, and the color coding is the blue, the darker blue is the highest. The groundwater is the highest source or the largest source of water in that particular area. The yellows and the reds are where the groundwater is not a high source, the low reliance on the groundwater. So you see, on the eastern part of US, you see there are large areas, or large number of counties scattered all over that are blue or dark blue. So that means they rely on groundwater. And if the groundwater aquifers are not recharged at the same rate that the water is withdrawn, there is going to be a problem in future, the near future or long future. And the problem is always that it's unpredictable. It can happen at very little advance notice, and that's why the concern is. So, in conclusion, what looked at is uh, what what we can look at what the current risks are for the water for a specific site of interest by location. Uh, what are the possible threats for the freshwater supply? Uh, One of the things a paper mill can do is benchmark its water usage with respect to a, a similar mill, and that way we know what is the potential for reduction in water usage. Obviously, as you reduce the water usage, your risk maybe is minimized correspondingly. And the actions that potentially can be taken or need to be taken either now or in the future in case the water supply, either quantity or quality, is going to be addressed. So hopefully uh, this will help making decisions, doing analysis, and hopefully it will help in whatever endeavors the listeners have as far as their job assignment. Okay, so that's all I have for today. Thank you for listening, and I'll be glad to answer any questions that may have.